So in the first round of Soccer's World Cup, we have a total of 32 teams. And in the first round, they're divided into 8 groups. So in the first round, we have a total of 8 groups and 4 teams per group. So for a given group, the number of teams, we'll call it n equals 4. And in a previous video, we showed that the number of games played in a group, we showed that that equals to n times n minus 1 divided by 2, and that equals 4 times 3 divided by 2, that equals to 6. And the way we show that is we drew a scoreboard with 4 columns and 4 rows, and we named our teams A, B, C, and D. Same here on the side, A, B, C, and D. And we said that a team can't play against itself, so we had to remove all the squares along the diagonal. And we said that in the group games, each team plays the other 3 teams once. So if you look at the scoreboard, we said that, okay, this square says that B plays against A, this square says that B plays against A, so we only have to count the number of squares once, and we said that the total number of games in a group, you can do that by counting the number of squares either below the diagonal or above the diagonal, and we show that equal to n times n minus 1 divided by 2. The question in this video is, can we come up with this formula without drawing a scoreboard? The answer is yes, and let's see how we can do that. So we have our 4 teams, A, B, C, and D. So those are 4 distinct objects. Those are 4 different teams, and we'll call them 4 distinct objects. And we want to select 2 at a time. So we're going to be choosing or selecting. So out of those 4, we select 2 at a time. And the important thing here is that the order of selection is not important. This is really the key point here. The order of selection is not important. What does that mean? It means if you select A first and then B, it's the same as selecting B first and then A, because at the end, A and B are going to play against each other only once. So the order of selection is not important. Since the order of selection is not important, that means here we're dealing with a combination. If the order was important, then it would have been a permutation. So what's the formula for a combination? So the notation here is n CR, and this is read as n choose R. So in our case, we have a total of 4 teams, so n equals 4, and we're choosing R at a time, so R equals to 2. So the general formula for NCR is factorial n divided by factorial R times factorial n minus R. This is the formula for choosing R out of a total of n. And if you're not familiar with factorial of a number, so the factorial of a number n equals n times n minus 1 times n minus 2, and we keep on doing that until we get to 2 times 1. So for example, factorial of 3 equals 3 times 2 times 1, that equals 6. Factorial of 4 equals 4 times 3 times 2 times 1, that equals 24. And we can write factorial n as n times factorial of the next number, next lowest number, factorial n minus 1, or n times n minus 1 times factorial n minus 2, and so on and so forth. So let's plug in the values. So we have 4 choose 2, that equals factorial 4 divided by factorial r, which is 2, factorial n minus r, so that's factorial 2. So this is equal to 4 times 3 times 2 times 1 divided by 2 times 1 times 2 times 1. So this 2 and this 2 cancel out with 4, and we're left with 6. So this is the same answer that we got here before. And if you want to derive this general formula, then the general formula is you have a total of n teams, and you're choosing 2 at a time where the order is not important. So this equals to factorial n divided by factorial 2 factorial n minus 2. And we showed here that factorial n can be written as n times n minus 1 times factorial of n minus 2. So this equals to n minus 1 factorial of n minus 2 divided by 2. Factorial of 2 is equal to 2. And n minus 2 factorial is unchanged. This term will cancel out with this term, and we're left with n times n minus 1 divided by 2. And this is the same formula that we derived before.